Hey guys, it's me, Miss Mills, and welcome to Mrs. Mills' Math Time. If you're watching this video, that means you needed help with the red plan. I know this doesn't really look like red, but I promise you this is red. This is if you need help with identifying if a graph or a table or if an equation is proportional or not proportional. So what I'm going to do for this video is I'm just going to go back to our notes and I'm going to go through them. This is review, so I'm going to go through them kind of quick. If you still need help with them, I would recommend watching the video that originally went along with it because it makes them a lot easier. All right, here it is. So here are the notes. So let's go ahead and talk about them real quick again. So this is going to be quick. So proportional, non-proportional notes. So proportional relationship, it means that two quantities are proportional and the two quantities are going to be constant. So that means if you pick two ratios of this graph, that the ratios when reduced are going to be the same number. If you're looking at a graph in particular, there's two things it needs to be for it to be proportional. One thing, it has to be a straight line. Cool. Second thing, it needs to go through the origin of the graph, okay? So for example, here's an example of a proportional graph. First thing, it's a straight line. So yeah, it satisfies the first thing. Second thing is it goes through the origin. The origin is the very center of the graph where the x-axis and the y-axis meet to make 0. If the line crosses that means it is a proportional graph. If you're looking at a table and you want to know, is this proportional or not? Well, again, pick two ratios. And the thing is, do never pick a ratio with a 0 in it. So pick two other ratios. And a ratio is y over x. So that means we would pick a y and put it over x. In this case, we have 25 over 1. That's the first ratio I chose. And the second one I chose was 75 over 3. Here's the 75 and here's the 3. Y over x. When 75 over 3 is reduced, it ends up being 25. That's going to be the case for all of these ratios. Therefore, it would be a proportional table because all the ratios are the same number when reduced. Okay? And if you're looking at an equation, your proportional equation is going to look like y equals mx. Okay? Here's the thing. Let me show you real quick. Is this still on? No, it's not. I have to do it. My bad. It's being slow. Okay, it's not doing it. So I'm just going to type it out on the notes real quick, I think. I'm going to do that. Yeah. So what that basically means is y equals mx. It means that it's going to be plus 0. Okay? So that means that if you're looking at a graph, the y-intercept is going to be 0 because when x is 0, y is also 0 because the line goes through the origin. Again, 0 and 0 right here. That means the line goes to the origin because this is an ordered pair right here, 0 and 0. Same thing here. The y-intercept would be 0, so this would be y equals mx plus 0. But you don't have to put plus 0 on any equation because it doesn't add or take away from anything. That's why this is gone. Okay, that's why it should only be y equals mx, where you just have the slope. Okay, so if you look at an equation and it looks like y equals mx, where m is the slope and there is no y-intercept, or the y-intercept is plus 0, that means it is a proportional equation. Okay? All right, so non-proportional relationships. When you're looking at a graph, if the line doesn't pass through the origin, it's not proportional. That's all you have to look for there. Okay? This line does not pass through the origin. It passes at, it looks like positive 3 when the line crosses the y-axis, which is this right here. It's at positive 3. So that means the y-intercept is going to be positive 3. That's a big thing. But it's not 0. So if the y-axis, or if the y-intercept is not 0, so that means this line crosses anywhere but 0. That means it is a non-proportional graph. Same thing here. First thing you got to look at is, well, is this a non-proportional table? Well, when x is 0, y is 10. That means that the line crossed on the graph, it crossed the y-axis at 10, not 0. That means it's not a proportional relationship. It's not a proportional table. But you can use the same thing as you did for the proportional table here and pick two ratios. Again, never pick a ratio with 0 in it. Pick two ratios, reduce them, figure out if they're the same number. If they're not the same number, it is not proportional. And then the very last thing, a non-proportional equation, it's going to be in the form of y equals mx plus b, where m is the slope and b is the y-intercept. If b is not 0, that means it is a non-proportional equation. So if you have a number right here, that means it's non-proportional. Guys, if you need more help with this, here's a video of me going into more in-depth explanations. This was just a quick video, or you can show up to one of my Zoom calls from 10 to 12 every day this week. Guys, I miss you, and I'll see you later. Bye.